sort that out. All right.
Okay. All right. Thank you again for your patience as we work through the technical difficulties here today. Yay! Yes, round of applause for Greg and also appreciate it. For coming up and helping out. My name's Ariel. I'm one of the founders of a company called Stagpoint Cloud. Quick survey, anybody heard of Stagpoint Cloud? Cool. Any Stagpoint Cloud customers? Users? I got a t-shirt for you. All right. Today's sponsors, also Sysdig. I'll spare you the brief on them because they're here. They're going to talk a little bit about what they do. They're going to show us a little bit about their open source tools today. And thank you very much for Squarespace for having us back, and Greg for coordinating around here. Next month, this is live. It's limited already. You're getting kind of early access to it. You go to the meetup page. Next month, on the 12th, we'll be at HBO. They're going to be talking a little bit about autoscaling and how they handle it there. And we'll also have Mark McBride from Turbine Labs. He's going to talk to us a little bit about some traffic management strategies for Lyft's Envoy. So really cool stuff. If you're anybody playing around with Istio, show of hands. Yes. So if you haven't, I highly recommend you should. And this will kind of give you a little preview of some of the cool things that you can do there. All right. KubeCon Europe. Let's keep the raised hands going. All right. I'm always surprised. So I'll be there. Hope to connect out there. If not, May 2nd through the 4th, consider Copenhagen. I've never been to Copenhagen. Should be fun. Here's a long time. Cloudflare, Argo Tunnel, Ingress. I was talking to somebody earlier about Ingress. If you have multi-cloud needs or Ingress challenges, we partnered up with Cloudflare to work on what was previously called Warp, but just got rebranded Argo Tunnel. We're looking for partners, so if you have some interest, go ahead to that link, that bit.ly link, or I see you with the camera. Hopefully it picks up that I'm playing around with the QR code. Did it work? Did it work? Did it get it? No? Works? All right, up front row it works. So the link will either come up to me afterwards. First up, from Sysdig, we'll have Michael. Again, he's going to be telling us a little bit about some of the open source tools that they have at Sysdig for troubleshooting containers. Afterwards, we're very excited to welcome back Dan, early member of the community, to tell us a little bit more about where they're at with Buffer, cool New York company. You guys in New York, you started in Europe someplace, right? But
yeah, we're remote.
You're remote, totally remote. So you guys are in the cloud?
Yeah, pretty much.
The cloud plays Buffer with some staffing here in New York. Thank you all very much for your patience this evening. I'm going to get out of the way and turn it up to Michael, who's going to talk to us a little bit about troubleshooting containers.
Where'd you get that Twitter handle for me from?
Oh my God, I didn't update it. It's not yours. I apologize. Typo. Good catch.
Yours is the one on the left.
All right. Important.
All right, let's hope this works. No jinx. How many people have heard of Sysdig before? Now, everybody's hand should go up because he just mentioned us. So a few of you. How many people have used the open source tool to troubleshoot a problem running on a system? All right, so a handful of you. So, or not a handful, 2 of you. So this will actually hopefully be an informative presentation for you. So I'm going to jump between slides and demo. If the demo goes south, as demos often do, then we're just going to do slides. But wish me luck. So Sysdig builds what we call the Container Intelligence Platform. What that means is we have some products that we put under this umbrella of container intelligence. We have a product called Cystic Secure, Cystic Monitor, and then an open source tool called Cystic Inspect, which is a GUI for opening Sysdig captures. And if you don't understand what a capture is, I'm going to explain that to you today. It was founded by a gentleman by the name of Loris Pop. You want to do this one? DiGianni. Yeah, it's easy. I always have trouble with names, so I always refer to my Italian to pronounce our founder's name. Sysdig is an open source project is how we started. We started in 2013, and there's been about 1 million downloads of the Sysdig open source tool. And it's really built around the same concept that we have with Wireshark. Who's used Wireshark before? Yeah, a lot of you. Me as well. Wireshark was the tool, the go-to tool that I would go and grab when I was sitting in an airport on an unsecure Wi-Fi connection, and my flight's delayed, and I want to see what everyone's doing on the network. Another cool thing, who's ever heard of Etherpeg before? Nobody. So Etherpeg was a cool tool that used the same concept of Wireshark that would sniff a network, and so it would be really cool that you would run it at like a conference during a talk or something like that. And what it would do, it would sniff the wire and it would see all the JPEGs or GIFs or PNGs that were being sent over the wire. And then they would just pop up the PNGs and the GIFs and the JPEGs on your screen for you as they were being pulled in over the wire. And so you would see that when the talk got really boring, a lot more images started flowing through. So if the talk gets boring, we start to see lots of images going across the Wi-Fi. We have about 300 enterprise customers, and we work a lot with companies such as Red Hat, Docker, Kubernetes, Community, Mesos, and so forth. So just to kind of give you a landscape, and then we're going to jump right into the open source. So we have our commercial products, and then we have 3 different open source tools. So Sysdig and Cystic Inspect are kind of sister projects of one another. Sysdig can create captures and read captures and give you a lot of information, much like what you can do with TCP dump. And then Cystic Inspect, think of that more like Wireshark, where you create the capture, you pull it back onto your workstation, and then you use Cystic Inspect to get more information out of that capture, and it's a GUI-based tool, and it's a little bit more user-friendly. And then Falco is a tool that uses the same concept that Sysdig does of capturing system calls on a system to basically write rules to say, if I ever see system calls that look like this, then notify me somehow. And that notification can be something like sending it to an ELK or EFK stack, sending it to a Slack channel, or whatever notification you would want that you could create. So, slide you want to take a picture of. Useful links to our open source projects. So our GitHub repository for Sysdig, Inspect, and Falco. They are open source projects, and we encourage contributions. If you want to know more about where we're thinking about where we need contributions and what things could be useful, if you're looking for a project to work on, find me afterwards, and I'm happy to talk and give you some suggestions of where what our roadmap looks like. So Sysdig is all focused around this idea of troubleshooting and forensics for systems specifically focused on containers. It has a powerful filtering language a la TCP dump. You can do real-time troubleshooting, and you can do also offline troubleshooting as well, and I'll show you an example of both. The way that architecture works is right now we have a kernel module that you put into the kernel. That kernel is basically taking a stream of system calls and puts it into an event buffer. And then there's a few other libraries that are used to actually go and create capture files, do some filtering, and then the command line interface or the command line user interface is provided at the Sysdig level. So basically what happens is you install it. Of course, the way you install it is curl sudo bash, right? Or you can download an RPM from a repository as well. And then you load in the module, and then you have Sysdig working, and you can begin to create captures of your system. So filtering is kind of the key for using Sysdig. It's very, very similar to what you would do with TCP dump. And what you do is you filter events. And these events are system calls. And so some examples of events are things like a file was opened, a network connection was opened, a command was executed. Basically, system interacting either with itself or interacting with other systems. And those are things that would all have to take place where you would have to go and talk to the kernel to have those actions take place. If it's code that's inside of your own code, like in your Node.js application or your PHP application, that isn't making a system call, like opening a file or opening a network connection, we don't necessarily see that unless you add in a special feature known as tracers. I'm not going to talk about tracers today, but if you're looking at trying to trace and troubleshoot your own application, tracers is what you would want to look at with Sysdig. And then you have operators, where you have field classes first, and then you have these operators. And these operators are things like equal to, not equal to, greater than, less than, and so forth. Contains is actually another very, very useful operator that you can use. So let's take a look at what Sysdig output looks like, and then I'll jump into a demo and give you some examples. So this is basically the raw string. We can see here that a process that was running on CPU1 that executed at this time, a process named HTTPD with this thread ID accepted a connection. And then this is basically the open, and this is the return. So if you're familiar with programming, functions have where you open it and then you return it and you get values back from the return. And sometimes when you call the function, you're going to pass in variables, and when the function returns, it's going to pass variables back to you. So you can see here that HTTP accepted a connection from a particular IP address to a particular IP address, and then some more information as well. And then you can see here that we're going to read from that connection, and what we're going to read is we can see the raw data that actually was passed over that HTTP connection. So we see the actual GET, the file that was requested, the protocol version that was being used, user agent headers, and so forth. And here's a little bit of a guide, and I'll post these slides later so that you can use them as a reference, but a guide to what each field means. I'm trying to advance slides. It doesn't work because it's not plugged in. So what can you filter? So these are examples of events that you can filter with Sysdig. So you can see open, close, read, write, kind of all the common I/O type operations that you would want to filter out. And then what field classes can we look at? So there's a whole bunch of different fields that you can use to filter on. Process name, information about file descriptors, and file descriptors are probably the most common one that you would use. It's a common one that you would use because most applications that you're going to be troubleshooting are going to have a network connection open. And of course, on a Linux-based system, network connections are a file descriptor. And so file descriptors have a whole bunch of different types, like IPv4 connection, IPv6 connection, and so forth. We also have some events for Kubernetes and Mesos as well that you can filter on. So you can say, I want to filter on a particular operation that's taking place in a particular namespace in Kubernetes or a particular pod, and so forth. I keep trying to use this. I should just plug it in because I'm going to keep doing that. Maybe. There we go. So file descriptors. So this is probably the one that you're going to use the most. And here's some good examples. Not only what you can actually filter on, but some examples down here. So you can see if I want to filter for all IPv4 connections, then I just need to say, show me all file descriptors of type IPv4. If I want to see all layer 4 protocol of TCP, I could do UDP, I could use ICMP as well. Then I could filter out that source IP, destination IP, source port, and so forth. Much like we can with TCP dump, right? So I'm seeing some droopy eyes, so let me change into a demo real quick. Why did this not do what I wanted it to do?
It's the theme for today.
Yeah. Big enough for the people in the back? All right. So if I do a Docker PS, I have a whole bunch of containers running. And I should have one called Nginx running. Let me just make sure. I do. All right, so I'm just going to start a capture real quick. And I start a capture by running the Sysdig command as root. And then I just need to give it a capture name. So I'll just call it k-nginx.scap. And I'm just going to drop that in the background. And then I'm just going to do a curl to localhost, and it's running on port 8081. And so I just got a page back from Nginx. So nothing too exciting. Let me foreground that process I just backgrounded, and I'll kill it. So let's begin to dig through this capture. So if I run sysdig, let's do the example that I just did. And I'm going to give it the file name that I just created. And I want to say fd.type equals IPv4. So what should I see here? Anyone want to guess? Connection from localhost, right? Yep. Yeah. So I actually see a whole bunch more than just a connection from localhost. And why do I see more than just a connection from localhost? Because I have a lot more things running on this. So let's get a little bit more specific with our filter. So when I created the capture, I wasn't very, very specific with what I wanted to capture. So what it actually did was it captured everything that was running on the system. So what I could do when I create the capture is I could be very specific, and I could say, only capture things from processes named Nginx. And then that would boil things down, or filter things down so that I'm only seeing the Nginx connections. So let's do that. And proc.name equals Nginx. As soon as I spell it right. And so now I can see here all the connections that Nginx opened up. And so I can see here that I've got the accept, and I can see it come from, well, it's not coming from 127.0.0.1 because we're using Docker. So it's coming from this address, open to port 80. And then I can see here the request that comes in, and I can see that the GET was sent, and I can start to see some of the headers. Now I don't see all of the information that was passed. So a lot of you have used Wireshark or TCP dump in the past. And so much like Wireshark or TCP dump, you need to specify how long you want the buffer, how long of the buffer you want to take. And so because we have a lot of data that we've sent across the wire, we need to say that we want a longer, what we call snap length, or size of the buffer. So much like you can with Nginx, or I'm sorry, with TCP dump, you would specify -s and then the size of the buffer, and then you would get more information from the protocol stream that you're sending across. You also can see the response from the server. So you can see that the server wrote the 200 message. And if I continue to go down, you actually see that I went and served a particular file, index.html. So let's take this just a little bit further, and let's look at this capture again. I'm like misaligned on my keyboard for some reason. All right, so let's say proc.name equals curl. And now we can see the other end of the connection. And we can only see this because we're running on the same host. You can't necessarily do this if curl is being run on another host and Nginx is running on another host, and then you're not going to be able to piece those two together yet. That's actually one thing that we want to add in, is the ability to merge captures, which you can do with Wireshark and TCP dump. And so I can see here that curl was started. They have the actual execution of the command, and I get a lot of information of where this command is running from. And so I can see that it's coming from this SSH client, and I see other session information as well. And if I go down, so this is a lot of information. So let's do something a little bit more. So let's ask a question. Let's say I want all files that curl opened up in etc. Right? So would curl ever open up files in etc when it executes? Yes. Well, the obvious answer is yes, but let's find out. And so you can see here that I've went and can see all the files that were opened up by curl in exe. So of course, it's opening up the linker cache. Then you can see here that it's opened up NS switch. We should also see things like resolve.conf opened up and so forth. We see hosts opened up. And so this is an easy way for us to get all of that information about what files curl is opening up when it's executing and so forth. So this makes sense? All right. So let's jump back over to the slides. So I already talked about this, so I won't cover it again. So let's look at Cystic Inspect. So Cystic Inspect is a tool that we launched, or project that we launched back in the summer of 2017. And to kind of tell you a little bit of our mindset of our CEO, he wrote this on vacation. So he's one of those gentlemen who will go off on vacation and will have this great idea and then just spend his entire vacation going and writing a tool or adding into one of our tools or something like that. So what Inspect is it gives you all of these different what we call views, and then it gives you these tiles. And the thing that's really powerful about Inspect is that you can overlay these tiles. And so let me just show you that quickly. And unfortunately, I can't make the font bigger, so you'll have to bear with me. And so if I go to Overview here, what this is a WordPress application. So I can go in and filter out some information. So let's first go and say, show me all the processes that were running on this machine when I took this capture. And we'll get information about during the duration of the capture, how much CPU was used by each process, how much memory was used by each process. The other thing that you'll notice, what container was this process running in? So we'll have this information about what containers were running on the host as well. I could even look at it from this perspective to say, all right, show me all the containers that are running on this host. And then if I wanted to, I could go in and say, all right, so let's drill down into the WordPress container. You can see all the processes that the WordPress container are running. And of course, this is running Apache, so there's a lot of processes that are running. And then if I wanted to, I could say, okay, for this container, show me all the files that were opened by this particular container. And you'll see this little breadcrumb as I click through these views. You'll see this breadcrumb trail kind of walk out. The other interesting thing that you'll see, that if you don't always know what filter that you would want to apply to a capture if you're working on the command line, the interesting thing about Cystic Inspect is it'll give you the actual filter that we're using here. And so I can see here that we've opened some stuff under var www.html. And I could actually go into this individual file and I could say, okay, show me the actual IO stream. Oh, that's not what I wanted. One of these this will work for. Huh?
Use bytes.
One of these will work for. I think I'm in the wrong capture. So I'm in this container. I can also see the IO by type, right? So there's different types of IO. So if I'm trying to troubleshoot a problem, and one thing about troubleshooting that's really important is you have to find what path you want to take, right? So if you're trying to troubleshoot an application and you're not sure why it's running slow, is it running slow because of network activity? Is it running slow because of IO? What you could do is go in and drill into IO by type. And I can see here that most of our activity was taking place over an IPv4 connection. I can also see file activity that took place. And if I wanted to drill down further, I could see, okay, well, what processes were doing the file activity? Since this is a WordPress container, it's of course going to be Apache. And I think the thing that's most powerful about Inspect is this ability to go and overlay different pieces of information. So I can say, show me all the HTTP errors that took place, and then show me all the file open errors that took place. So I can see here that there's a bunch of HTTP errors and file open errors that seem to be happening at the same time. And then what I could do is drill down into one of these particular drill into this one. And so I can see everything that was happening during this. This is really hard for you all to see, but during this 819 milliseconds on the system. And so if I had a particular event that I was trying to troubleshoot, or if I wanted to see what was actually happening when a command was executed, I could begin to drill down and get very, very granular with my search. I could also see things like server ports or connections that were opened up during this time as well. And I can see what commands were actually opening up those connections as well. Make sense? Yes?
If you can go back to the previous view, where you have the HTTP filer. So theoretically, you can click on the HTTP errors and the file open errors and probably do some application layer correlation.
Yes. You can also, so in this case, so the question was, that's a good point. That's something I skipped over. Thank you very much. I'll give you a sticker afterwards. So any of these tiles you can actually drill down on. And so if I click on this drill down, I can drill down and I can see the actual reads and writes that were taking place. As promised, the sticker was delivered. And I can see the actual type of HTTP error that was actually happening at that time. Another interesting thing that you may not necessarily think of is process errors. So who's ever had to troubleshoot odd errors like file descriptors running out, right? And you may not necessarily get an error message in your application. You might just be told that can't write a file or can't open a file, right? What you can actually see are the process errors that are taking place, and you can see here that I had 48 different errors taking place. If I drill down into this, I can see what type of errors that were being thrown as well. And then, unfortunately, we don't have a go Google this error, but then what you would go and do is go and Google that error and understand more why that error is taking place. And you go to, what is it, Stack Exchange and so forth. Another interesting part of Sysdig is that we have these things called chisels. Chisels are essentially what makes those views possible. It's a script written in Lua, so if you were looking for a project to contribute Lua to, or a chance to learn Lua, this would be a great project for you, who's not looking to write more stuff in Lua. But what it allows you to do is aggregate, analyze, and report on a sequence of events. And so those views that we're actually seeing is actually we're just executing a Lua script on that capture or on that data. So let me give you an example of a couple different ones. So if you wanted to see all the HTTP requests, you would use HTTP log. If you wanted to see top processes by CPU or top containers by CPU, then you can use that very easily, and it'll give you that information. There's a whole list of these, so if you just wanted to reference them quickly, they'll be in the slides later when I post them, and I'll tweet them out. My Twitter handle is right here, and I'll post them on SlideShare after this. So one other thing in the time that I have left that I wanted to show is that you can also look at Kubernetes information. And so the one that I always like to show is, because I think it's pretty powerful. So if I run Sysdig, so Sysdig is a live tool, kind of like Inspect. Inspect we can't run live, but this is a curses-based tool, and I gotta zoom this out, or otherwise, that's not what I want to do. Well, for some reason it doesn't want me to zoom out. My terminal is angry at me. Maybe it's a user error.
Yeah.
Did you say yeah? All right, so I can look at information that's going on the system. I have the same types of views. So if I wanted to see all of the containers that are running, I could go in and look at those containers. And you can see we've got several containers running, 22 different ones. If I wanted to see, that's not what I wanted to do. I can go in and say, show me all of the Kubernetes pods that are running. And in this case, I don't have any Kubernetes pods. So what I'm going to do is I'm going to bring one up quickly. That's not bringing it up, that's actually deleting it. All right, and then I can do curl localhost, and there is nothing running on localhost, and that's fine. But what I wanted to show was if I go and drill down and look at my views, and what I wanted to show is if I go and look at processes, I can't find it. Anyhow, we'll skip this and I'll show it to you afterwards if you want to show it. But what we can actually see is the protocol interaction between Kubernetes and other services like Docker. So if I wanted to drill down and see what was actually happening on the system, I know how to do it now. Hold on. So if I go and look at Echo, I can see all the protocol streams that are happening and going through here right now. And if I go and look at, oh, I don't remember the filter. I actually have to look at the actual pipe that's being sent, and I forget the actual file name. And you want to filter on the particular Unix pipe that's being used between Kubernetes and Docker, and I forget the actual name of the file. But you can see here, we see a lot of that information going back and forth when I look at this F5, and I can see all of the information that's taking place for a particular process. I can look at Hypercube and the API server, and I can see all of that traffic that's taking place between Kubernetes and anything else that's running on the system as well. And so you can see the actual raw protocol going across. You can see me getting nodes, it checking in, and so forth. You can use all of this data to then go and do a filter. You see some of these coming across where it's actually modifying an endpoint and so forth. You can use all of that information to then go and filter and troubleshoot why Kubernetes may not be interacting correctly with another system or another API or so forth. So I'll be, yes, question?
Can you capture from there?
You cannot capture from there, you have to capture from Sysdig. But you can capture the Kubernetes metadata. So if you wanted to go and filter on a particular pod or a namespace or something like that, you can do that very easily. So in the minute and 25 seconds that I have left before Ariel kicks me off stage, let's talk about what Falco is. So Falco is a behavioral monitor tool, and so it'll detect suspicious activity defined by a set of rules. It uses the same filter language as Sysdig does, and it has full support for containers and orchestrators as well. So you can alert on Kubernetes metadata, so a particular pod does something, or if you want to then, if you see abnormal activity, then you can also include the Kubernetes information in the alert that you send as well. So things like a shell is ran inside of a container, right? System binaries were overridden. Somebody tried to change a container namespace, probably trying to escalate privileges of a container. Non-device files were written in root. So things that people do often to try and hide things. And we shipped 25 different rules out of the box that are kind of focused around these kind of container best practices. And so the way the rules look, you can see here the rule for right below a bin directory. So we have different macros, and so basically what will happen is this expression here will get substituted and replaced here. And so basically, if anything in this directory is open for writing, and it's not by a package management process, then we need to throw this alert that says a file below a known binary directory was open for writing by this user, by this process, and that's the name of the file. If you run it in Kubernetes output mode or container output mode, then we would also add in other fields in here as well. you have any other questions, I'm here. Dan and Derek are local to Derek. Wave Derek. There you go. Got to teach them how to interact with people. They're both local to New York. I'm actually based out of Ohio. And as I said, my Twitter handle is up here as well. So thank you very much, and I'll be around for questions later.
Thank you.
Well, Dan's setting up. If anybody has like a question, you can probably shoot at you. Jerry, you got one already. I saw one in the back. No question? All right, Jerry, you get it.
Since you're acting on every system call, what's the over event?
So for,
In both passive mode and active mode.
yeah, we tend to find it pretty small, usually under 5%. In the commercial tool, we actually cap it so it doesn't go ever be up above 5%. In the open source tool, it can actually take over a system, but we tend to find that fairly rare, unless it's a really, really, really busy system. And if the system gets overwhelmed, what we'll start to do is drop events from the event buffer, and just not add the events to the event buffer. So on an overwhelmed system, you could actually lose system calls.
So, but if I had this, let's say on a live system that I want to turn on and off, because I have a production system, I don't want it to affect performance, but I may want to be able to turn it on when it's in an idle mode.
Yes.
What's the cost? It still has to go through every event.
Very, very minimal. So we find it about 2% CPU. Dan, did you want to add something?
Yeah, I just want to add that normally you would have some type of alert or an event. Normally, you would have some type of alert or event to cause that capture. You wouldn't have it running the whole time. Our age is pretty small, but it's kind of impacting grabbing all the syscalls. But when you're creating a capture, it bumps a little bit up, but it's only during the time of the capture, which is typically like 5 seconds or what have you. So there's not much impact. You're not having to run throughout, right?
Yeah, and the other thing is you want to try and filter as much as possible to try and keep your captures as small as possible, because otherwise you can get a very, very large capture very, very quickly. Thank you.
Thank you.